Hello and welcome back to Dr. Logic Awkwardly Does Logic. In this video, we're going to look at the modal reduction principles for S5. This is something we've been working to for a while, so some of the pieces that we need are already present in videos that we've already done. In particular, I'm going to get up my whiteboard so that we can start noting things down, because we have shown that S5 is a proper extension of S4, meaning that every theorem of S4 is also a theorem of S5. We already have all of the modal reduction principles from S4 in S5. So this is great. Among other things, here, let's get our list up. Modal reduction principles of S5. They include these principles, which were already principles in S4, namely that necessarily phi is equivalent to necessarily phi, and possibly phi is equivalent to possibly phi. So anytime that we have two of the same modality in a row, we can drop them, we can drop one of them and have just one. Now, our initial axiom that we investigated adding to system T in order to get S5 was this E axiom. You'll recall it says that if P is possible, then it is necessarily possible. With this axiom and a bunch of the other theorems that we have from S4, we can get two more modal reduction principles. The first one is that possibly phi is going to be equivalent to necessarily possibly phi. So this is one half of it, but we can get the other direction on the basis of adding E to system T. The proof of this is actually enormously straightforward. First, we take a substitution instance of the T axiom that necessarily possibly P implies possibly P. So this is uniform substitution. We've just replaced possibly P for P in the T axiom. Then we can write down the converse of that through our E axiom. So that's just an axiom. And then propositional logic says if you can prove A from B and B from A, then they are logically equivalent to each other. So we've got necessarily possibly P, if and only if possibly P, through propositional logic on the first two. Now, exactly the same way that we were able to derive this, the second principle from the first one, just by contraposition, uniform substitution, negations, double negations, etc., we can get a corollary of this one as well, which is that necessarily phi is going to be equivalent to possibly necessarily phi. So I will leave this as an exercise. If you would like to do the proof, I'm happy to check your results, but it's pretty straightforward and follows the same sorts of patterns of other ones that we have done in the past. So what does this mean if these are the modal principles that we have? First thing to notice is that you've got one modality on the left-hand side and two modalities on the right-hand side. So these are reduction principles. We are always going to fewer modalities. Then what we have is anytime that you've got two, essentially, it's only the one right next to the non-modalized formula, or rather just whatever phi happens to be. Maybe it has more modal operators. We don't know. Those are the ones that matter. And all of these other ones, they just don't. So what the S5 modal reduction principles say is that no matter how complex or how complicated or how many different modalities you have in your string of modalities, now maybe there's some negations in there, let's stick a negation in there, let's stick a negation in there, etc. So suppose you've got something that looks like this. Once you've dealt with all of the negations, driven them through to the other side, so this, we would change the boxes for diamonds, and we do all of our ordinary reduction things, and then we've got two negations and they cancel out. What the S5 modal reduction principles say is that the only one that matters is this one, and we can just cut down all of these other things. So the next question that we have that you might want to ask is, Well, how many distinct modalities are there in S5, given that we've got these incredibly robust reduction principles? So I will give you the answer, and then, I don't know, maybe next video we'll give a proof of it. It's fairly straightforward. Nah, we won't bother proving it. You can do it yourself. The distinct modalities in S5, that is, the modalities that are not equivalent to each other, are not reducible to any other modalities, are the empty modality, negation, box, not box, or box not, doesn't really matter, and possibility, and negated possibility. These are the only distinct modalities in S5. Everything else can be reduced to one of these. So if you do want to try proving this, it's going to be the same sort of proof as showing the distinct modalities in S4. What you need to do is prove that each of these are in fact distinct from each other, that they are not equivalent. And then any other more complex modality, prove that you can reduce it to one of these 6. And you'll be able to do that very easily given these modal reduction principles. So there you go. Here we have our modal reduction principles in S5. You now know the number of distinct modalities that we have. There are a couple of interesting theorems that one can prove, which are sort of modal reduction principles, but not quite, but will be very useful for things that we want to do later. So we'll take a look at those next time, and so kind of drill into the logic a little bit before pulling back up and looking at some of the meta properties of the system. Until then, take care. Happy proving. Cheers.